I'm Gil Levin. I'm currently an adjunct prof in the Center for Advanced Scientific Concepts of the College of Liberal Arts and Sciences of Arizona State University, Tempe. For a long time, I ran a company I founded way back in 1967, which is what really got me into this trouble. My path to Mars began on the beach at Santa Monica, and it involved the optics of looking at bubbles. Complicated? Well, not really. I was working for the California State Health Department and was patrolling the beach at Santa Monica, picking up water samples to determine when the water should be quarantined to keep people from swimming in it. In those days, primary sewage flowed right out on the beach. There was virtually no treatment. The trouble was, it took nearly a week to get the results back from those tests. And that's the optical part. The tests were run by inoculating a test tube of nutrient broth with a little bit of the suspected water, and then waiting for bubbles to develop. Well, I got the idea, why wait for the bubbles? If I tag the nutrients with radioactive carbon, the carbon dioxide coming out, formed by the bugs eating the nutrient, which produces the bubbles, will be detected long before visible bubbles, because radiation detectors are so sensitive. So, to make a long story quite short, some 30 years later, I was able to put together an experiment that went to Mars to look for life by picking up a sample of the Martian soil. The Viking spacecraft lander did that, and inoculating it into a small tube in which a squirt of radioactive nutrient was placed. Were any microorganisms present, hopefully, they would recognize the nutrient, eat it, and give off radioactive gas. Well, no one, including me, was very hopeful this would work on Mars. However, the possibility of life on Mars was so astounding that NASA described the whole experiment of looking for life on Mars as perhaps the greatest experiment in the history of science, which is puzzling, because while they still say that, there's something wrong in their lack of pursuit of it. At any rate, surprisingly, as soon as the first squirt of nutrient hit that Martian soil, we got a big bulge of gas coming out. And it came out for the entire 7 days, or Martian sols, of the experiment. That was astounding. But we had conceived of that possibility being false, being absolutely conducted by chemicals in the soil rather than microorganisms. So we had a test for that too. We had a control experiment, carefully designed, really designed by NASA. And it was, if you ever, unlikely, got a positive response, you would take a duplicate sample of that same soil and put it in a little tube, just like the first sample, but now heat it to 160 degrees centigrade, a temperature they selected as killing any microorganisms known on Earth, but not high enough to destroy oxidizing chemicals that might have given a false answer. So this is called the control. You run the control, and if it's positive, then the agent that was active survived the heating, so it's not microbial, it's chemical. But if it's negative, you've killed something that had been alive, and that's the confirmation that it was indeed a positive response for living microorganisms in the soil of Mars. That is what happened. Not only did it happen, but at Viking 1, it was duplicated, and it happened again. And the control happened again. At Viking 2, 4,000 miles away, we got a similar response, positive. I decided to make the control a little more rigid. You know, maybe 160 degrees could kill some chemistry. So I reduced it to 50 degrees C, and the response was reduced 2/3. Something had happened at 50 degrees C. But more than that, while we waited for the season to rotate in Mars, we held the active sample in a chamber for 2 months before we dared move it again because it had been so cold. We shot the LR experiment again on that same sample that had been active, and after 2 months stored in the dark at 10 degrees centigrade, a very modest temperature, it was dead. There was zilch in the way of a response. That is pretty hard to explain away chemically. However, the naysayers were up to it. And at first they proposed ultraviolet light is activating the soil, and that's what you're detecting. So we challenged that. We asked and had the engineers agree to send that arm out one morning just at dawn, move a rock that had been there probably 1 million years, take a sample under that rock and test it. It was as positive as the other positive sample. Gone was the UV. Next, they got the idea that there is hydrogen peroxide or some strong oxide covering the entire surface of Mars. And that is killing microorganisms and destroying any organic matter, because the instrument NASA sent to identify the organic matter everyone knew was on Mars. They doubted there was any life, but no one doubted there was organic matter because it came from the same sources as it did on Earth. That instrument found 0 organic matter. Well, now NASA was really faced with a problem. One experiment says life, the other experiment says no organic matter. Ignoring the fact that the experiment that said life could detect as few as 10 cells on Earth, which it had done, remarkable sensitivity, and the fact that the experiment looking for organic matter required the organic matter of 1 million cells to detect it, they wrote it off and said, nope, no organic matter, quote, there goes the ball game, end quote. For the 37 intervening years, NASA and other astrobiology scientists have been explaining away, or attempting to explain away, the labeled release, my experimental results. They've been unsuccessful. No one has ever reproduced, in the laboratory or even in theory, a chemical that will react in that manner and give those control results. But it did not bother them. They still contend that it's some weird chemical. One of them even said perhaps it's chemistry turning into biology. We may have arrived at Mars at an historic time. Well, since then we've learned so much about life on Earth that it exists every place, except perhaps in red-hot lava. But wherever you go, up, down, sideways, there's something alive under conditions that are sometimes as bad as any on Mars. And yet these bugs thrive on Earth. Since my experiment, NASA has refused to send another life detection experiment to Mars or any place. Every time I have sent in an upgrade of my original experiment as a proposal for a new spacecraft, it's been rejected. I was told directly by the head of the Mars program, if you send in another proposal to send an experiment to look for life on Mars, it will be immediately rejected. That's bad science. The reason they give is because if they got another equivocal answer, which they now admit, we're not sure it wasn't life, but it's at least ambiguous. If we got another ambiguous answer, it would hurt our program drastically. So we're not going to take a chance. That is not science. That is politics. science demands, if you get a positive result, you go back, replicate it, and then expand it and learn more by the same technique. Well, we had already replicated it. It worked 2 times at Lander 1. It worked 2 times at Lander 2. Now, what more replication do you want? I had come up with a method of improving the experiment by making it chiral in nature, distinguishing left and right hands. You know, your left and right hands are not identical. You can't place one on the other. All living organisms that we know of use only left-handed amino acids and right-handed carbohydrates. I had mixed them in the solution I sent to Mars because they wouldn't give me 2 instruments to keep them separate to see if there were a difference in the responses. I now propose to test them separately. Every astrobiologist I've spoken to has agreed if the organisms ate only one isomer, the left-handed or the right-handed, that would be proof of life. Chemistry cannot distinguish between those isomers. Biology always does. Those proposals were similarly rejected. Now, in the intervening years, several experimenters have demonstrated there was something wrong with the instrument that went to look for organic matter on Mars. And they have explained it away, they have impugned it. None of the original complaints against the validity of the labeled release experiment remain, except the general statement, it's the consensus of astrobiologists that life was not detected. Now, you know, science doesn't work by consensus. As a matter of fact, when Jim Martin set our Viking 1 down on the ground, he had delayed putting it down for 2 orbits because he had seen these rocks on the ground. He took a vote of the scientists assembled there, 17 of us. All 17 said, let's go down. We're going to run out of time. And he says, well, thanks for your opinion. Science is not a democratic process. We are not going down. And he went 1 more orbit and got us down safely. What I'm trying to do is get us down safely to rid us of the paradigm that we are alone. We are not alone. There is life on Mars, and that means there should be life throughout the cosmos. The next experiment should be to send up that chiral experiment to see whether life on Mars is the same as life on Earth or different. If the chirality were different, that would be a stupendous discovery. It would open up the cosmos to life.